All right, today's lesson we're going to take a look at what it means by a combination. All right, so my main goal is I'm learning to organize data to make counting outcomes easier. And to be successful, I should understand what a combination means. All right, I should understand what a combination means. I'll be able to distinguish between when we use a permutation and a combination. So we talked about permutations earlier in the unit. We're going to talk about what makes them different. I'll be able to solve problems that involve groups of items. And I'll be able to solve problems that involve selecting items from different sets of groups. So that's what we're going to take a look at and what that means. So what is a combination? So a selection of items from a group of items without regard to order. Okay? That's what a combination is. So the idea here is there's no order. We don't need the order of things, but they occur. All right? And since the permutation formula returns a value for all arrangements, so all arrangements are permutations. All right? This means that order matters. In order to eliminate the order for counting the number of combinations possible, we must divide out the repeating combinations. So the idea is very similar to the last information where we had permutations with identical items. That's what we kind of looked at. Okay? Now, that's from what's being said here. Okay? That's the additional one we're dividing in. Okay? So sometimes our calculators look like this. Okay? And sometimes it looks like this. All right? So you got to find that combination button. So if I'm looking at my calculator, I've got NCR here, and usually it's paired up really close to the permutation button. If you were looking at Desmos, it'll be in the same area as where you found the permutation and the factorial button, but that's going to be important. So the first question here is just straight calculation. So what does this mean? Well, if I'm looking at this, and I'm going to do the long form, but we'll understand what it means. So my n is 5, my r is 5. So I'm going to have 5 factorial over 5 minus 5 is 0 factorial, and then 5 factorial. Well, if I do 0 factorial on my calculator, let me get down here. 0 factorial is 1. Okay, so this actually ends up being 1. And what this really means is I have 5 items, and I have 5 in a group. And the question is, how many groups can I make? That's the answer we're saying. So if I have 5 items in a group, and I choose from 5 items, I can only make one group because all the items have to be there to use the group. Same thing here. If I have 6 items and I have a group of 3, all right, that's what it's kind of looking at. I can use the formula, all right, 6 minus 3 and 3, right? But I'm not saying you have to use this all the time. You don't have to use this extension. I'm just showing you what it means, all right? So I'm going to type that in my calculator. Zoom up a little bit. I'm going to do 6 factorial divided by 3 factorial divided by 3 factorial. Okay, so I have 20. All right, but if you want to just do 6C3, you still get the same answer as 20. all right? If I went back here, if I did, clear that, 5C5, I get 1. It's as simple as that. All right? How many different sampling dishes with 3 different flavors could you get on an ice cream shop from 31 different flavors? So the first question you want to ask yourself is, does order matter? Well, if I'm having the dishes, does it matter the order that they come in with? No. So I'm using combination. So I have 31 flavors, and I choose 3. So 31, choose 3. And that's it. 31, choose 3. So 4, 4, 9, 5. That's it. So this is the important part. Can we distinguish between a permutation and a combination? Combination, order does not matter. All right. Sometimes we have different things. Zoom out a little bit. How many ways can you choose 6th grade 12 students and 6th grade 11 students from a group of 10 and a group of 14, 12 and 11 students? So we got this word and. So and means to multiply. So what you have to look at the question. We have 10 grade 12s, and I'm choosing 6. And I'm choosing 14 grade 11s, and I choose 6. All right, so we have a group. So what I want you to do is, I want you to write down what should go here and there, and what sign should go there. All right, push pause, write down what you think it should go there. So hopefully when you did it, you had 10 choose 6 and 14 choose 6. And we're choosing the multiply because this is an event that's occurring at the same time. And we can all do this in one step. All right. So if I was doing this in one step in my calculator, this is what it would look like. 10 choose 6 times 14 choose 6. And done. So you can all do that in one step. If you want to do it separately and then multiply after, that's fine. But we're going to focus on the words. Tell me what it means for those things. All right. Back to school shopping. Miss Martin's favorite thing to do. All right. So back to school shopping is Miss Martin's favorite time to do in the year. This year, she went to Staples and had a choice of 5 different binders, 6 types of calculators, and 3 types of pencil cases. Determine how many choices she had if she selected 3 binders, 1 pencil case, and 2 calculators. So we have to look at what we have total. We have 5 binders. We have 6 calculators. And we have 3 pencil cases. And when I'm thinking about this, all right, I sometimes thinking about it kind of like the line things where I'm multiplying. All right. So I have 5 binders, and I have to look at how many am I choosing. I'm choosing 3. Choose 3, so that's 5C3. Then I have to look back and say, well, I want 1 pencil case. So I have 3 total, and I choose 1. 3, choose 1. I have 2 calculators, 6, and I choose 2. And I can all do that in 1 step. Writing down these words here helps us to build that idea. And then I can do that in 1 step. 5, choose 3, times 3, choose 1. Move it up a little bit. Times 6, choose 2. 450. So I have 450 different groups or choices I could make by making those things. Okay? Question B. She only had enough money to select 2 binders or 2 calculators. So, still a combination, but what does the or mean? What does that mean? It means I have to add the outcome. So, I have to look at my binders. I have 5 binders. Choose 2. Or, so I'm adding 2 calculators. Well, I have 6 calculators to choose from. I choose 2. And I get that answer. Because I'm not choosing any of the other ones. So technically I can go 6, choose 0, times 3, choose 0. And just so that we know, anytime you choose nothing, so if I look at 6, choose 0, there's only 1 group that's allowed for that. One group is, if I go back over here, there's only 1 way of picking that group. So choosing nothing or choosing everything, there's always 1 way of doing that. All right? We just find our answer. 5C2 plus 6C2. All right. She wanted to purchase 5 items total. So, in our pairing here, we're talking about total. We don't care about what items are. Just you're choosing 5 items. Well, we have to figure out how many total items do we have. So we look at it and say, well, how many total items do we have? Well, if I look up here, I have 5 and 6 and 3. I have 14 total. So I have 14 total, and I want to choose 5. So 14C5. So that's choosing any of them, totally random. I could have had 5 binders, or 5 calculators, or 3 pencils and 2 calculators, or 3 pen cases, 1 binder, 1 calculator. Doesn't matter. Okay. All right. So for the last question, what I'm going to do is I'm going to let you try it. I want you to push pause. And I'm going to write down the answers that I'll explain my thinking based on that. So go ahead, push pause, and then you can write down the answer and then try your thinking afterwards. All right, so we're back. So for the first question, any 5 people, well, there's 14 total, 9 for female. That means there's 5 males. And we want to choose any 5, doesn't say gender type or whatever. So 14C5. That's pretty straightforward. in terms of choosing any 5 people. B, Maddie must be on the committee. So that means that if I was looking at this, we're going to make the assumption that Maddie's female. That means we have to choose 4 other people. Well, there's 13 others to choose from. So 13 choose 4 gets my 715. All right, or you could do times by 1, which doesn't change anything. The last question is the hardest. There must be at least 2 males on the committee. And the idea of this is we have to be able to sort the outcomes so that it's easy to see and they're mutually exclusive. So the idea here, there's no overlap between these. So if I look at this and I say to myself, at least 2 males, that means there has to be 2 males or 3 males or 4 males or 5 males. And if I look across here, while there's 5 males to choose from, choose 2. But you have to ask yourself, do I have a group of 5? I don't, because there has to be 3 females. Well, that's where the 9 choose 3 comes from.